Hello, Math 152 students. This is Rochelle, and I'm going to do, from section 6.2b lesson notes, I'm going to do example 7. This is going to have us revolve an area about an axis that is not the x or y axis. So this relates to, I believe, numbers 8 and 9 in your homework. So our first job is to draw the region. So I am going to go ahead and, whoops, I'm going to draw my axis way down here because I can see that I'm revolving around y equals 6. So I'm first going to draw e to the x plus 2. That's going to look somewhat like this. I suppose this is, let's erase that. Oh, that didn't work. I'm going to erase that guy. Try that again. E to the x plus 2 would be up a little bit higher. And we've got x equals 0, so I'm going to draw x equals 0, which is this line. And we have y equals 0, which is this line. And then we have x equals 1, which will be, I'm going to go ahead and exaggerate, it's going to be out here at 1. So I know that this is the x-axis. This is the value 1, this would be 2. This right here is going to be up at 3. To give you an idea of where it intersects, because if we plug in 0 there, we're going to get 3. So I'm going to go ahead and keep, so 4, 5, 6, 7. Let's say 7 is right about there. So the region that we are looking at, if we go by green, green, blue, and red, is this trapezoidal looking region, except it's curved. That is the area, that's the region that's described right here, and we want to revolve it around the line y equals, did something weird happen? Y equals 7. So this is the axis, y equals 7, and we want to revolve this around that axis. So the way that's going to look is this point here, which if I plug in 1 into here, I'm going to be at 4 point something, so it's a little bit off here. I'm just going to go ahead and put that point right, I'm going to put that point right here. This region's going to be, see how this is a solid line here, so if this is at 7, this would be up here at 14. That makes sense because it's going to double. And then my red curve is going to be right here. That's going to go, this distance is 4, so this would be 10 right here because it would also have a distance of 4. Oops, wait a minute. I'm sorry, this distance is 3. This is going to be at 11. So again, what's happened here is we're making kind of this circle at the end, and there is a hole in the middle of it. So on the outside it looks like a can, a very, very short can, but on the inside there's a bit of a funnel. And we're looking for the volume of the can, including this dense part here all the way around. And so what we're going to be doing when we slice it is, since it's around a horizontal axis, just like when it was around the x-axis, we did a dx, we're going to do the same thing here, because if it's revolved around this axis, the slice is this vertical slice. I'm being kind of quiet because I'm thinking. Apparently I can't think and draw at the same time. I'm going to try and draw this thickness a little bit for you so you can see the actual washer a little bit here. So there's a washer. I'll go ahead and pull it out here. That looks like this shape right here. It's got a little bit of, thickness if you want to have it here, so you can kind of see that it's a little bit three-dimensional. So again, this is a washer. It's got a hole in the middle of it. And so my volume is, once again, I notice that I have a delta x here. So my volume is always going to be, it's going to be dx, but this is, again, it's going to be the area function, and this is going to be pi times r, the radius of the outer circle squared, minus pi times the radius of the inner circle squared. And this right here, remember, is my area function. That's the area for this circle right here. And that's going to be between a and b, and a and b have to be x values. And so the two x values that I see here are going to start at 0 and then end at 1 here. And I'm going to go ahead and bring my pi out in front. So then I'm just going to have a radius squared, this being the outer radius, and then the inner radius is going to be squared right here. And it's going to be a dx. Now the tricky thing here is trying to figure out what those radii are. Now if you notice, it looks like my outside radius isn't going to change, remember, because it's in the shape of a can. So my outside radius, let's go ahead and try and put that in terms of maybe green. My outside radius goes from here all the way down. So it goes from the center line all the way down. And if we look at it, that distance right there is simply 7. So my outside radius is simply going to be 7. Now my inside radius is a little bit trickier. My inside radius is right here, and it depends upon this red function. So I'm going to try and use yet another color here. Let's see if I can find another color. Let's use orange. Now this height, oh my goodness gracious, get away. Ah! Sorry. This height right here is, remember, that is my y height. And that y happens to be equal to e to the x plus 2. Okay? This entire, oh goodness, this entire height here, remember, is a height of 7. That's the one that we had here on the outside. So if I want to find this height right here of this radius, I'm going to need to take 7 and subtract this y value. So this red distance right here is going to have to be that 7 minus this, for crying out loud. Oh gosh, what happened to my OneNote? All right, bear with me. I guess I'm going to have to find the OneNote again. And I'm not going to redo this video like I've redone so many of them. That's the wrong OneNote. Excuse me. I apologize for this, but I refuse to have so many takes. So here we are back here. And this region that I was talking about right here has to be this 7 minus this y distance that was measured in, sorry. Oh goodness, that doesn't look right. Measured by this y distance. So I'm going to go ahead and just write it over here. And so what we're going to have here is 7, which is a y value. See if I can get it to actually write. 7 minus, then I have to subtract this orange, y equals e to the x plus 5, and I'm going to need to write it as e to the x plus 5. So here, having a hard time getting this thing to write, it's going to be e to the x plus 5. And that whole thing is going to be subtracted from the 7 because it's now about a different axis. And that's the stuff that is pretty darn hard. And so what I think I'm going to do, I'm going to go ahead and simplify this a little bit to make it look a little nicer. I'm going to have 0 from 1. This is just going to be 49 minus. Now the thing that's going to be squared in here is 7 minus e to the x minus 5. So I might rewrite that as 2 minus e to the x if I combine these two terms together. And this guy, again, I would just plug into my calculator. And I'm going to get a total of about 95. Whoa, 0.981 units cubed. Now what I just realized is this is the answer for if y equals 6. You will notice I chose 7 here. That is so not right. So this number should be a 6, and this number should also be a 6, which would make this number here a 1. And if I do that, then I'm going to get this correct answer right here, because I misread the problem and wrote y equals 7, but everything will be the same except for that. So what I'm going to do is I think I'm going to try and do a couple more of these examples because they are challenging, especially one that's revolved around a negative axis as well as one that's revolved around a vertical axis. So, more to come.